If we know that the x-intercepts of the graph are negative 6 and 2, what are the two ordered pairs that we actually have here? Good. Negative 6, 0. What's the other one? 2, 0. Okay. So what this is going to be is this is going to look exactly like what you guys did in the notes yesterday, and that is this page where we took 2 points and you guys wrote through everything and talked about, all right, this is what's happening first, this is what's happening second, and you're changing the points. We're just doing that again, just in this format. All right, so it's very similar. Okay, is this the input of the function, or is this on the outside? Input. Input changes your graph how? Left to right. So this is horizontal movement. Okay, and anytime you have an input, what do we know about the operation? It's opposite. So we have x minus 3, but what do we really need to be doing? Plus 3. So we're going right 3, which is x plus 3. Okay, well here's our 2 points here. So what is negative 6 plus 3? So this is going to be negative 3, 0. And then if I have 2, 0, and I go right through, we're going to have 5, 0. All right, what's happening here? So we know it's going to be x minus 7 because we are moving left 3. And negative 6 minus 7? Negative 13. And then 2 minus 7? Negative 5. Okay. There's a couple things happening in this next one. Okay. What is the negative doing here? It's going to be the opposite x, and then what does that do to your graph? Opposite x. Reflects over the y-axis. So reflection, so reflect over the y-axis. That's our negative x. What about this 3? Is that part of the input, or is that on the outside of the function? That's the outside of the function. All right. Because of that, is that going to be a vertical or horizontal change? Yep, outside is always vertical. We have the value of 3. If it's a vertical, is that going to be a stretch or a compression? Stretch by how much? It's on the outside, right? So the outside we do the operation as is. Inside is when we do the reciprocal. All right, so this is going to be a vertical stretch by 3. So it's going to be 3 times, every y value is 3 times greater. So we have 3 times our y value. Okay, so if we perform this reflection, what are our 2 new x values? 6 and negative 2. What happens when we do the stretch? 3 times y, but then what happens? It's just 0. So your stretch you're not going to see on the x-axis. You're going to see on all of your other points, though. Okay? So your intercepts do not change because of stretches, just the rest of the graph.
If the original thing was like, say it's like negative 6 and 2, the original thing, then you would multiply 3 and 2.
Yes. You would just take your y value times 3. Very good. Okay, so we have here 3x. Is this the input or outside the function? This is our input. So that means we know there's a change horizontally. And what is happening here? It's a compression by how much? By 1/3. So horizontal compression by 1/3. Anytime you have an operation that's part of your input, you're always doing the opposite operation. So instead of multiplying by 3, you're actually dividing by 3, which means you're multiplying by 1/3. So this is 1/3 times your x values. So instead of negative 6, what are we going to have? And instead of 2, yeah, just 2/3. For this next thing, I think it's going to be really helpful to draw a sketch of a random graph. And I say random because they give us this function g of x, and we have no idea what the function is. It could be square root, cube root, x squared, like we don't know what it is, right? But the one thing we do know is that it's decreasing on this interval. Now, if this is an interval then what kind of values are this 3 and 7? These are actually x values, all right? I think the common thing looking at this is you assume this is an ordered pair, but it tells you it's the interval 3 to 7, and because it's talking about, anytime you talk about increasing and decreasing, that's always going to be the x values then, okay? So what I'm going to do down here, as a reference, I'm going to draw 3, 7, and I'm going to make up a random function, and it's just going to be linear because that's the easiest way to draw decreasing. And I know I'm going to put a point here. I'm going to call this 3y1 because I don't know the y value. And then I'm going to put a point down here and make this 7, and it has some other y value that I also don't know. Now if I draw this function, or I'm drawing a straight line, okay, this function is decreasing from 3 to 7. Does everybody agree? Okay, now again, this may not be the actual function. Like maybe, you know, I have a curve here and it's decreasing, right? That could happen, but either way, no matter how you put it, you know, whether it's up here, it could be down here, but it would still be going down. It doesn't matter as long as you draw something that's decreasing from left to right. Any changes that are made to this function would be similar to any changes made to another function that is also decreasing, okay? So it says, well, over what interval is g of the quantity x plus 1 decreasing? So this is the same function because this is my g of x I have here. But now it says g of x plus 1. So what is that doing to my function if I have g of x plus 1? So this is, careful, moving to the left because this is the input. So this means we're moving left how far? Left 1. So what does that mean I'm doing to every x in my function? So it's x minus 1. So here I have my function 3 to 7, and I'm literally moving it 1 to the left. So now where is my function decreasing then? Because it would go from here to here. I'm just moving this left. Ooh, horrible dotted line. But you guys get the point. This would be from 2 to 6 instead because I moved it left 1. So the whole function would be now decreasing from 2 to 6 instead of from 3 to 7. Okay.
Could you also just look at what fulfills that equation? So like saying that if it's x plus 1, it can't be any less than 2 inputs. Because you have to end up with 3.
Yeah, you could definitely think about it like that, conceptual thinking, for sure. I like to write stuff out because not everybody always grasps that, so I kind of like to have the both. But if you didn't have any work and you put 2, 6, like you would get full credit. All right, so for the next part then, how is our graph changing here? It's going right 8. And so what are we doing to each x? Plus 8. All right, so I'm not going to draw this one because there's not quite enough room, but the idea is now I'm taking this 3 to 7 and I'm moving it 8 to the right, which is going to change my 2x value. So I now have the interval is going to be 11, so 3 plus 8 is 11, and 7 plus 8, 15. Okay. Now this next part can be pretty confusing. So let's go over this. We have this graph, negative g of x. What does that mean? What's happening here? It reflects over what? It's the opposite what? So on the outside or the inside? This is on the outside. All right, so the outside always changes vertically, right? So so if we're having a vertical reflection, it reflects over the x-axis. Okay, so it's a reflection over the x-axis. Okay, so even though we don't know what g of x is, the one thing we do know, it's decreasing from here to here. So we can even use the sketch of our random function, and we're going to actually reflect it. So if it reflects over x, where I once had 3y, I'm now going to have, well, 3 negative y, right? And then for this 7y2, I'm now going to have 7 negative y2. And then what happens to my function then from 3 to 7? It's actually increasing now. Okay, so this is actually increasing from 3 to 7. This is where drawing a sketch, oh, so helpful, right? Because otherwise you're looking at that and it's like, I don't know, like you're kind of guessing and stuff, right? But we don't want to have to guess. We just want to have, visually some idea of what's really happening, all right? And then for the last one here, g of negative x, what kind of a reflection is that? Reflects over the y-axis, all right, because we have the opposite x, so whatever x we had, we're now moving horizontally. We know it's a horizontal change because the negative's on the inside. Anytime you have anything on the input, it's always going to be horizontal movement. So by reflecting over the y, I have 3y. What would be my new point? So negative 3y and then negative 7y. Now notice, all right, someone had pointed out, it's on this interval from negative 7 to negative 3. The reason why it has to be this interval is because when you do this graph, we want to look at what happens between negative 7 and 3. And what's happening between negative 7 and negative 3? It is increasing. Okay, so this did change, okay, because of that reflection. All right, everybody good with that? Yep. Okay, last example. All right, so this example, we're kind of going backwards. It's going to tell us the shifts that are happening, and we are going to write a new function because of it. We're going to go in order, so we're going to do this first. We're going to take this equation and then change it using this, and take this equation and change it doing this, okay? So for the first part here, we have to shift left 3 units. Now, is that horizontal or vertical? Horizontal. And for my function, when I write my function x squared, is horizontal part of the input or is it outside? It's part of the input, right? So I have y equals, my input here is changing. Now if I'm going left 3 though, what does my input need to be? X plus. It's always that opposite. So if I put x plus 3, I'm being shifted left, okay? So this is x plus 3. All right. A reflection over the y, what does that do? That's the opposite x value. So it's the opposite of the inside, okay? But here's the thing then. If you come over here, all right, this is going to require a little bit more work because we already have values on the inside. So we're taking the opposite of the whole inside, not just x, because it's really the opposite of the input, okay? So we come over here. And what I'm going to do is put a set of parentheses squared, all right? So everything in the bracket is inside my function, and I need to do the opposite of what was inside. So this was my input, x plus 3. I need to do the opposite of the whole thing, and so now we really have the opposite of x minus 3 quantity squared. All right, and then the last one, if we do a reflection over the x-axis, then it is what? The opposite of y. Y is all of the outside, okay? So if that happens, then we have y equals, well, here's my input part. My input is not changing. It's just going to be the opposite of the outside. I don't have any numbers over here, so I can just go ahead and put a negative and call it a day. Okay, I want everybody to try 5. Go. Okay, we have our root x function, and I need to take my whole function, because that's y, minus 6. So this is going to be y equals root x minus 6. All right, I know this is on the outside because it's a shift down. I know anytime I have a vertical change that the operation is the same. So to move down, I'm actually putting minus 6. To reflect over the y-axis, that means it's the opposite of the inside. Now what's nice about this one is the inside of my function is actually just x versus having x plus 3 as my input. So here we had to distribute the x to get this minus x minus 3, but here I don't need to distribute anything because I only have x. So y equals root negative x minus 6. All right. Now here I have the opposite of y, but really when we're doing the opposite of y, it's the opposite of the whole function. So that means that I need to do the opposite of what my function currently is. Oh, I did that last class too. I don't want that there. Okay, so I need to do the opposite of root negative x minus 6. And what happens then is when I do the opposite of my function, I need to distribute. And so you're left with negative root negative x plus 6. Okay. How many of you got that right?